Okay, so the first thing that we're gonna go over is the exponent laws. Okay, before we start with the exponent laws, I wanna just go over a few things about terminology or vocabulary. Okay, so when about exponent or exponential functions, I'm talking about a base and an exponent. Okay, so if I have a base, which is, let's say I'm gonna call it b, my exponent is gonna be any number n. Okay, so we call this the base, and we call this the exponent of the base. Okay? In order for me to be able to use the exponent law, I must have the same base when I'm either multiplying, dividing, or doing power to the power. So I must have the same base, otherwise I cannot use the exponent law. Okay? So let's say if I have 3 to the power of 2, right? And I'm multiplying it by 3 to the power of 4, right? What is my base for the first one? 3. What's my base for the second one? 3. As you can see here, my bases are the same, right? So then I can use the exponent law to simplify. If my bases are different, so let's say if I had this, right? Because in this case, my bases are not the same, I cannot use the exponent laws to simplify my equation. Okay? Make sense? All right. So here are the different laws that we have. We have the multiplication law, division law, power of a product, power of a quotient, and the power of a power, zero, negative, and negative exponent quotient. I'm going to talk about all of these, and then we're going to look at some examples. So when I'm looking at the multiplication law, so when I'm multiplying two exponents, two bases with the same base and different exponent, when I'm multiplying them together, what happens is I can leave the base and add the exponent. So let's look at something that looks like this. If I have, I'm going to take the same example that I've written before. So if I have 3 to the power of 2 times 3 to the power of 4, right? So basically that's the same thing as saying 3 to the power of 2 is what? 3 times 3, right? And then times, what's 3 to the power of 4? 3 times 3 times 3 times 3, okay? So you see that in this case, I'm multiplying 3. How many times by itself? 6 times, right? So 1, 2, 3, 4, 5, 6. So that's the same thing as writing what? 3 to the power of 6, right? So we call this the expanded form, but we don't usually use this, right? We don't usually use this because then if it's 3 to the power of 15, are you going to write 3 times 3 15 times? No, okay? So, but I'm just using this to show you where they got the formula that I'm going to talk about right now. So every time, what happens when I'm multiplying, basically, if I add 2 and 4, what do I get? 6. Okay? So basically, what happened here is I kept the base is 3, and it stayed 3. And I took my exponent, and I added them. Okay? Which gives me 3 to the power of 6. Okay? So this is where the formula, this formula came from. I have the same base, right? And I'm multiplying them. So all what you have to do, keep the base, add your exponents. Does it make sense to you guys? Does this formula make sense now? Okay? Now, the second formula that we use is called the division law. So with the division law, it's the same idea, right? I have to have the same base, otherwise I can't use the division law, okay? So if I'm going to take the same example, And I'm going to do 3 to the power of 4 divided by 3 to the power of 2. Okay? 3 to the power of 4, we said it's 3 times 3 times 3 times 3. Yeah? Divided by 3 to the power of 2, so that's 3 times 3. When I'm dividing, I can simplify the numbers, right? Because there's multiplication, so basically I can go and do this. This and this cancel, right? This and this cancel, so I'm left with 3 times 3. What's 3 times 3 if I want to write it in exponent format? 3 to the power of 2. Yeah? Do you guys agree with what I just did right now?
So that would be the answer for the division law?
That's right. So what do you think I did with my exponent if I don't want to actually expand? What do I do with my exponent? I subtract. In this case, it looks like it's division, but it's not. It's actually subtraction. I'll show you another example, right? So if I do 3 to the power over 3 to the power of 2, okay? So that's 3 times 3 times 3 times 3 times 3 over 3 times 3. Okay? So gone, 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 gone. I'm left with 3 to the power of 3, right? To get 3, 5 minus 2 equals 3. Okay? So whenever I'm dividing, if I have the same base, okay, I can just take my exponent and subtract them. Okay? I keep the base the same. You see that my base did not change. It stayed as 3. Okay? I just subtracted my exponent. This is where this formula came from. This is where this formula came from. Okay? You have the same base, you're dividing, you subtract your exponent, m minus n. Okay, then I'm going to move to the power to the power. So I'm going to move to this one. Okay? So what power to the power means, it's this, something that looks like this. If I have a to the power of 2 to the power of 3. Okay? You see that I have 2 powers here? Right? I have the inside power, which is the power of 2, and I have the outside power, which is the power of 3. Yeah? Okay, if I want to expand this, how can I expand?
Maybe A2 3 times A2 times A2.
Okay, so it's A2 times A2 times A2, yes? Because I have A2 3 times to the power of 3. Are we okay with that? Now, we learned earlier, if I'm multiplying with the same base, what can I do to my exponent? I can add them. We learned that with the product rule, yes? So basically, I can take my base, and I can add 2 plus 2 plus 2. What's 2 plus 2 plus 2? 6. If you want to take the 2 and the 3, what can you do to the 2 and the 3 to give you 6? Add them, subtract them, or multiply? Multiply. So basically, whenever I have power to the power, my law says I can take my exponent and multiply them. So I don't have to do all of this work. You just take the exponent, multiply them, and that would give you the answer. Okay? So far we covered 3 laws. Multiplication, so if I'm multiplying, what do I do with my exponent? Add. If I'm dividing, what can I do with my exponent? Subtract. And if I have power to the power, what do I do with my exponent? I multiply them. Question? I can right now. Maybe after. Maybe after. this is where the law am to the power of n is basically you keep the base and then you multiply your exponent. Are we okay with this? Now what happens if I have a times b to the power of n, right? So basically with this one, you're gonna have to bring your exponent in, distribute your exponent in for each letter or each number inside your bracket, okay? So let's say if I have a times 2 to the power of 3, okay? Or 2a to the power of 3. Basically, that 3 needs to go as an exponent for each thing inside that bracket. So that becomes 2 to the power of 3 and a to the power of 3. Okay? That only happens if I have multiplication and division. If I have addition, so let's say if I had this, it does not work. Okay, I can't do this. So you have to be careful with this. Only when I have multiplication, and then we're going to cover the division in a bit. When we do exponent law, we do it again, but I don't do it like slow like I do it with my grade 11C, okay? I do it fast, so make sure that you kind of grasp some information here, okay? I'll reteach it again when we do the exponent, but it won't be slow, okay? So, I'm just going to explain, like I'm going to give you another example here. And let's see if we can do that. So, whenever I have something like this, I'm going to have to pretend that the exponent on the 2 is 1, right? If you don't have an exponent, it's actually a 1, okay? Because 2 to the power of 1 is 2, okay? So what happens here is I have to think about that exponent 4 that's going to multiply into both terms, okay? So that's going to be 2 to the power of 4, because 1 times 4 is 4, and then a to the power of what?
12.
You guys agree it's 12? Yes, because 3 times 4 is 12. A lot of times students forget to bring that exponent 4 for the 2. So a lot of times students write 2a12. No, it's not. Okay? 2 to the power of 4 is 32. And it's not 2. Sorry, 2 to the power of 4 is 16, and it's not 2. Okay? So these are not the same answers. This is not correct. This is wrong. Okay? You have to remember to bring your exponent in for each term inside the bracket. We're good? Now the second rule, which is there is a mistake in this in here. It should be a over b in bracket to the power of sorry. Never mind. It's a to the power of n over b to the power of n. So there should be an n on top of it. So this is similar to what we just did with the exponent with a product 1. So if I have, let's say, a over b to the power of 3, that's the same thing as writing a to the power of 3 over b to the power of 3. Okay? Because remember, what's the exponent on a? What's the exponent on b? 1. If I multiply 3 times 1, that's 3. And then same with here. Right? If I had, let's say, a squared over 2b to the power of 3, and then to the power of 4. Just giving you some harder examples, right? What happens for this one? For the a? A to the power of 8. Because 2 times 4 is 8. How about for the denominator? 2 to the power of 4. 2 to the power of 4. B to the power of 12. right? Because the exponent right here is a 1, right? 2 to the power of 4, and then b 3 times 4 is 2.
So is that how you would write it as solving it, or would you have to then?
You can, if you want to do an extra step and do 2 to the power of 4, which is 16, you can do it. Okay? Are we good with that? Okay, so we've done 1, 2, 3, 4, 5. Now we're going to the zero exponent law. The zero exponent law says that anything to the power of 0 is equal to 1. There is a reason for that. Like they did not just came up with it. Let's look at this. A to the power of 3 divided by a to the power of 3. What do you get? What do you do when you have something like this? Subtract the exponent, right? So keep the base. I have the same base, right? So I keep the base and subtract the exponent. Yeah? This is my quotient division law. So what's 3 minus 3? So that's a to the power of 0, yeah? Okay? If you are going to forget about the exponent law and you're dividing something by itself, when you divide something by itself, what do you get? 1. Right? If I have 10 chocolate bar and there's 10 of you, each one will get 1 because 10 divided by 10 is 1. Yes? I have a3 divided by a to the power of 3 divided by a to the power of 3. Technically, these cancels and they give me 1. But if I use the exponent law, it's a to the power of 0. Guess what? A to the power of 0 and 1 are equal to each other. Okay? And that's why anything, it could be 1,000 to the power of 0, it's 1. Okay? Are we good with that? Then we have the negative exponent. Anytime you have a base with a negative exponent, basically what they say is you flip your base and then you make it a positive exponent. I'm going to teach you why, okay, why that happens, and then I'm going to show you a few examples. So let's look at this. What do you do when you have something like this? I'm dividing same base. What do I do with my exponent? Subtract the exponents, right? So it's 2 minus 5, yeah? What's 2 minus 5? A to the power of negative 3, okay? Good. Now, let's try something else. Let's try something different. If I want to expand this, okay? So that's a times a over a times a times a times a times a. Yeah? So if I want to cancel, what do I have left? What do I have on the top? I have nothing, which is 1, right? I have 1 over, what do I have on the bottom? A to the power of 3, right? These two are exactly the same question, right? I got this from this. If I use the exponent law, it gives me this. If I use the expanding format, it gives me this. So that means these two are equal. What do you notice between these two? What's the similarity? What's the difference? What do you notice have happened? So one is more simplified, but one has a positive exponent and one have a negative exponent. You guys see that? They both have the same base, which is a, right? This a has a negative 3. This one has a 3. The difference is the one with a positive 3 is in the denominator, right? So what happened actually, you see this one? has a base of 1. Anything has a base of 1, right? If you don't have a denominator, it's a denominator of 1, okay? So what happened is these get flipped. So that becomes 1 over a, and then your exponent becomes positive. So these are exactly the same thing, but written differently. Okay? They're equal to each other. In math, technically, we can't leave our answers with a negative exponent. Okay? We should put it as a positive exponent. And to change it from a negative exponent to a positive exponent, we say flip the base and make your exponent positive. Okay? So you flip the base, 1 over 8, and make your exponent positive. Okay? Let's look at an example here. If I have b to the power of negative 7, how can you write that as a positive exponent? 1 over b to the power of 7? You agree? What's my base here? What's my denominator here? 1. Right? Anything that doesn't have a denominator, it's a denominator of 1. Flip it, it becomes 1 over b. And you make your exponent positive. So that's plus 7. Okay? Flip, make your exponent positive. Now what if I already have a denominator? I have, let's say, a over b to the power of negative 3. How can I make that positive exponent?
Flip the fraction.
Flip the fraction. So flip your base. It becomes b over a to the power of positive 3. Okay? So flip the base, make your exponent positive. Okay? So these are all the rules that we have for now that we should have learned in grade 11 for the exponent law. Okay? Now, when it comes to solving the exponent thing or simplifying, you're going to have to use multiple laws together. Okay? It's not going to be only one. Right? It's going to be multiple. So we will revisit this when we get to the exponent unit. We'll revisit this, but then we'll learn something new added to it. So, let's look at this example right here. So I have 7 to the power of 2 times 7 to the power of negative 5 divided by 7 to the power of negative 1. Unless, and this is where a lot of times it becomes tricky. Unless your exponent that's outside is negative, don't flip until the end, right? If the exponent that's outside is negative, you can flip first, that's fine, okay? But if these are like little exponents inside are negative, don't flip. It's gonna make it harder for you, okay? So what do you see on the top? What's happening on the top?
Multiplication.
So I have multiplication. Do I have the same base? Yes. When I have multiplication with the same base, what do I do with my exponent? Add them. So the first step I want to do is I want to add my exponent on the top. So 2 plus minus 5. And then I'm going to leave the bottom as is for them. Okay? What's 2 plus minus 5? Negative 3. So I have 7 to the power of minus 3 over 7 to the power of minus 1. Are we okay with that so far? You guys understand where we got the negative 3 from? Okay. Now, my bases are what? What's my base? What's my base? 7. So my base are is 7 for both numerator and denominator. I'm dividing, so what do I do with my exponent? Subtract them. So that's going to be, keep the base the same, And that's going to be negative 3 minus negative 1. What's negative 3 minus negative 1? Negative 2, because what happens negative and negative q becomes positive, right? So basically that's the same thing as writing negative 3 plus 1. Okay? Because negative times negative is positive. Okay, now, because my final answer has a negative exponent, this is where I'm going to have to change it to a positive exponent by flipping my base. Okay? So right now, I can end up my question and say this is the same thing as 1 over 7 to the power of 2. Done.
So just like that, turns into a positive.
That's right. So what I did is, because there's an invisible 1 here in the denominator, right? So flip the base, so it becomes 1 over 7 instead of 7 over 1, and make it to the power of 2. Are you guys okay with this? So I have x squared to the power of 0 plus x to the power of 0 squared. How can I simplify it? So what do I have here?
2 times
2 times 0 is what?
0.
0, right? I have power to the power. You guys understand that this looks exactly the same as this one, right? As the power to the power law. This right here looks exactly the same as this, well? So, that means I have to multiply my exponent. So 2 times 0 is 0, so this is x to the power of 0. Plus, how about this one?
X to the power of 1.
X to the power of, what's 0 times 2?
0.
0. Anything to the power of 0 is?
1.
So that's 1 plus 1, which is?